All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. Sorry I can't be there at school today. I'm suffering through some professional development out in Canton right now. Yeah, watching some state football. Anyways, here's what I want to do for today. I would like you guys to work through section, you see right there we have 5.4. I'd like you to work through the practice problems there that we've already done, and I don't want you to do all of them. How about we just do all the odd ones, okay? So you're going to do the odd ones from the first page, and you're going to do the odd ones from the second page, okay? So if you need to work with a partner, that's fine with me. Just want to make sure you get through those problems. You can work through this as a bonus with a partner as well. Now there's a couple things I would like to point out to you. The bonus problem is set up like this. We're going to shade in. It says solve the inequalities and color in the integers. Now what are integers? Integers are all whole numbers and their opposites. So all the integers, whole numbers and their opposites, that are defined by the inequalities to reveal a mathematical symbol in the grid below. Okay? And so down here, you've got all the equations that you're going to solve. So for the first one, you guys know how to get x. Okay? Obviously, we're going to divide both sides by 2. And you're going to get x is less than or equal to negative 18. Okay? So if we look up here, we want to find all the numbers that are less than or equal to negative 18 and shade those in. Okay? All the numbers less than or equal to and negative 18 and shade those in. And you're just going to work through those next 7 problems there, and you're going to do the same thing up there. Okay? So all possibilities to any of those inequalities, but they have to be integers. Any fractions, decimals, you won't want to shade those in. Now, the lesson that I want to go over with you guys today is this right here. We have some word problems. And I know and I understand word problems are a little bit more difficult. Okay? But I want to talk you through numbers, I don't know, 1, 2, and 3. And then I'll let you guys maybe do numbers 4 and 5 on your own there. Okay? The one thing I would encourage you to do as you work through these problems is to make sure that your answer makes sense with the problem. So sometimes, you know, coming up with these inequalities, absolute value inequalities, can be difficult. But at the same time, as I look at my final answer, I'm like, yeah, that doesn't make sense. Okay, so I have to go back and make sure that it does make sense. So reading the first problem here, it says speedometers. The government requires speedometers in cars sold in the United States to be accurate within plus or minus 2.5% of the actual speed of the car. If your speedometer reads 60 miles per hour while you are driving on the highway, what is the range of possible actual speeds at which your car could be traveling? Okay, so no, Jacob, you can't use the excuse, my speedometer said this, and the cop said, no, you're going some other mile per hour. Okay. They know that all the speedometers are within plus or minus 2.5%. Now, before we actually go ahead and formulate what that will look like as far as inequality, I want to remind you, plus or minus 2.5%, if I write that out, 2.5%, what is that as a decimal number? I know there's a decimal there right now, but if I were to get rid of the percentage sign, what would that look like as a decimal? Okay? Now remember, if you've forgotten, this is actually 2.5 out of 100, right? If we divide that out in our calculator, that gives us this. Okay, so don't forget, a percent, you move to an actual number, move it 2 decimal places to the left, the decimal point. Okay? So as I look at this, we want to know the maximum and minimum values, okay, that our speedometer has to read that we're actually going. Okay? So as I think about this, I'm thinking, well, if I know I'm traveling 60 miles per hour, and this is the low end down here, well, I could subtract 2.5%, so that's a decimal point right there, 0.025 of 60. And that should give me my low end, right? Taking 2.5% of the 60. But there's a high end as well, and so I could actually do the same thing but in the opposite. and take 2.5% of 60 and then add that onto the 60, okay? And so when you do that, you've got your low end and your high end of all cars within the United States. So as I look at this, we're going to be going 58.25 miles per hour, pretty much 58 miles per hour, and then 61.25 miles per hour. So anywhere from like 58 to 61 miles per hour is an acceptable range when you're going 60 miles an hour, okay, for that speedometer. All right, now these next couple, we actually have to set up the absolute value inequalities, okay? So we start with something that's kind of basic, simple. As long as we can read and put it into numbers, we're good, okay? Now this next one says this. Pete is making muffins for a bake sale. Before he starts baking, he goes online to research different muffin recipes. The recipes that he finds all specify that the baking temperature is between 350 degrees Fahrenheit and 400 degrees Fahrenheit inclusively. Write an absolute value inequality to represent the possible temperatures T called for in the muffin recipe Pete is researching. Okay? Now, here's what I want you to know. All the temperatures lie between 350 and 400. So maybe I do something like this. Let me get rid of, let's see here, make this white, make this real big. Let's get rid of this and right over the top of this. Okay? All right. So if I go ahead and black, there we go. So my number line, okay, all of our values are between 350 and 400, okay? All right. They don't include 350 and 400. They're between 350 and 400, okay? Now, if we look at this, temperatures between 350, yeah. If we look at this, this is an and sequence. Remember, there's no arrows here. It's in between. And when we're doing an absolute value inequality, we know that it's going to be something, it's got to be less than, right? If it's an and sequence, it's got to be less than. Now, where does everything else go? Well, I need to find the middle number between these two values, okay? That will tell me how much plus or minus we're actually working with, okay? And so as I look here, the middle number is 375 degrees Fahrenheit, okay? I've got 25 here and 25 there, okay? And so what I'm going to do is this. I know that the temperature, T, all right, has a reference point of 375 degrees Fahrenheit. And it changes 25 degrees either way, okay? And so if you can think of it this way, this is your middle value or midpoint. And this is the change that occurs to get to your high end and low end values. Okay? Now, a moment ago I said, hey, make sure that your inequalities make sense, that your final answer is the answer you're looking for. So if we set these up like we did the other day, T minus 375 is less than 25. So if I add 375, we've got less than 400. Well, that's good. And if I do the other way, T minus 375 is greater than negative 25. If I add 375 to that, I've got 350. And isn't this what we were looking for? The values between 350 and 400. Greater than 350, less than 400. Okay? So I realize that this setup right here is a little bit, ooh, that's kind of bad. Try that again. There we go. Is a little bit different, okay? But my hope is that if you use that understanding on the next couple, you're going to get it, okay? So if we take a look at the next one. Let's see how this will play out on the next problem. Okay. It says archery is an Olympic archery. In an Olympic archery event, the center of the target is set exactly 130 centimeters off the ground. To get the highest score of the 10 points, an archer must shoot an arrow no further than 3.05 centimeters from the exact center of the target. Write an absolute value inequality to represent the possible distances d from the ground an archer can hit the target and still score 10 points. Okay. Well, this no further, okay, I'm going to say that this is, if you have a target, okay, let's think of this. There's the bullseye. Not a very good circle, but close enough. All right. And the center of the bullseye, if I see this, it might even be resting almost on the ground. This distance right here is 130 centimeters. Okay, my guess is the circle is probably resting on the ground, so it's probably more like this. Okay. Now from there, whoop, go back. Okay. From there, we can be 3.05 centimeters away. Okay, did I say this should be centimeters? Centimeters, okay. So this 3.05, anywhere within this small little circle right there, okay. Now, if you think about that, you have the middle of this object that we're aiming for, okay. There's 130 centimeters here. There's 130 centimeters here. So the midpoint that I was referring to on the previous problem, if I go back to that, the midpoint that we're referring to, that's the 130 centimeters. Okay, that's the middle. So if I set this up, and this is going to be less than or equal to, because the range, okay, the change of the high and the low, if I go back to this problem right here, the change from the high to the low from that point was 25 degrees, right? So if I look at this, the change of all the values away from that center is going to be 3.05. Okay? So we wrote the absolute value inequality. Now we need to graph the solutions to the inequality. So again, and this is the easy part. I know that once you guys are here, you guys are going to be good to go. Absolute value of x minus 130 is less than 3.05. I don't know why I just put those parts down. Let's erase that. Doop, doop. There we go. Okay. So if I go ahead and add 130, okay. So the greatest distance I can be from the ground, okay, I should add the or equal to, is 133.05 centimeters. So from here, plus the 100, or up 130, and then from there up another 3.05. That's how we get the 133.05. What just happened? Undo. There we go. I don't know why that just went off. For the other one, x minus 130 is greater than or equal to 3.05. And if we add 130 to that, oh, that should be negative. If we add 130 to that, 126.95. Okay. And so if you think about that, we go up 130, then we come back 3.05. That's how we get that value there. So the range is between those two. So we're going to look at 133.05, 132, 133. We're just beyond that. Okay. And we're at 126.95. We're almost 127. This is the range that would give you a 10-point score shooting above the ground. Okay? All right, as long as it's centered. All right, so what I'd like you to do is, again, going back to the first page, let me go back there. Let's see here. The first page and the second page, remember you are just doing, I believe I said the odd ones. Okay, so you're doing the odd ones there. You have a chance for bonus, which needs to be turned in on Monday. And then I want you to finish up numbers 4 and 5, see if you can figure those out. Okay? So I hope you have a great weekend. I look forward to seeing you guys on Monday. Good night.